Article 517 in the National Electrical Code addresses healthcare facilities. Section 517.30c specifically addresses raceways for fire alarm systems in healthcare facilities. It states that raceways shall be metallic, rigid, and of an approved type, or shall be rigid, non-metallic, and listed as suitable for the purpose. The conductors shall be installed in accordance with the requirements of Section 300.22. This means that approved raceways for fire alarm systems in hospitals include metallic, rigid raceways such as electrical metallic tubing, or EMT, and rigid, non-metallic raceways listed as suitable for use as raceways for fire alarm systems. EMT is an approved wiring method for fire alarm systems in hospitals, as specified in NEC Article 517.30c. Hospital-grade metal-clad cable is also an approved wiring method for fire alarm systems in healthcare facilities, provided it meets all applicable requirements of NEC Article 517.30. The key takeaway is that compliance with the National Electrical Code, specifically Article 517, is essential when installing fire alarm systems in hospitals and other healthcare facilities. Understanding the specific requirements for raceways and wiring methods is crucial to ensure safety and adherence to regulations. Using approved materials like EMT or hospital-grade NEC cable, and following the guidelines in sections like 517.30c and 300.22 helps to achieve this goal. Always consult the latest edition of the NEC and local amendments for the most up-to-date requirements, as codes can change between editions and jurisdictions. When installing electrical systems in healthcare facilities, meticulous attention to detail and adherence to code requirements are paramount. This is to ensure the safety of patients, staff, and visitors. Fire alarm systems are particularly critical, as they play a crucial role in detecting and responding to fire emergencies. The NEC provides specific guidelines for these systems to ensure their reliability and effectiveness. Article 517 focuses on healthcare facilities and provides additional requirements beyond those found in other parts of the Code. Within Article 517, Section 517.30 addresses wiring methods. Subsection 517.30c specifically deals with raceways for fire alarm systems. It mandates that these raceways must be metallic, rigid, and of an approved type, or rigid, non-metallic, and listed as suitable for the purpose. This means that EMT, being a metallic and rigid raceway, is an acceptable option. Rigid non-metallic conduit, often referred to as Schedule 40 or Schedule 80 PVC conduit, can also be used if it is specifically listed for use as a fire alarm system raceway. The listing ensures that the conduit meets certain performance standards such as fire resistance and low smoke characteristics. In addition to the raceway requirements, Section 517.30c also references Section 300.22, which covers wiring in ducts, plenums, and other spaces used for environmental air. This means that conductors installed in the fire alarm system raceways must comply with the requirements of Section 300.22, which may further restrict the types of conductors that can be used and how they are installed. Hospital-grade NEC cable is another approved wiring method, as long as it meets all the applicable requirements of Article 517.30. NEC cable consists of insulated conductors enclosed in a metallic sheath. Hospital-grade NEC cable has additional features, such as a green insulated grounding conductor and markings indicating its suitability for use in healthcare facilities. When using NEC cable, it is important to ensure that the fittings used to terminate the cable are also listed for use with NEC cable and that they provide a proper ground connection. In summary, when installing fire alarm systems in hospitals, electricians have several approved wiring methods to choose from. These include EMT, rigid non-metallic conduit listed for fire alarm systems, and hospital-grade NEC cable. It is crucial to consult Article 517 of the NEC and any local amendments to ensure compliance with all applicable requirements. Furthermore, proper installation techniques and the use of listed materials are essential for ensuring the safety and reliability of the fire alarm system. Remember that the NEC is updated regularly, so always refer to the latest edition for the most current requirements. Also, be aware that local jurisdictions may have additional requirements that are more stringent than the NEC, so it is important to check with the local electrical inspector before starting any work. When selecting a wiring method, consider factors such as cost, ease of installation, and the specific requirements of the project. EMT is a popular choice because it is relatively inexpensive and easy to install. Rigid non-metallic conduit can be a good option in corrosive environments. NEC cable can be a good choice when flexibility is needed or when it is difficult to install conduit. No matter which wiring method is chosen, it is important to ensure that it is installed properly and that it meets all applicable code requirements. This will help to ensure the safety of the building and its occupants. In addition to the wiring methods discussed above, there are other requirements in Article 517 that apply to fire alarm systems in healthcare facilities. These include requirements for emergency power, grounding, and overcurrent protection. Emergency power is required to ensure that the fire alarm system will continue to operate even during a power outage. The emergency power source must be capable of providing power to the fire alarm system for a specified period of time, typically 24 hours. Grounding is required to provide a path for fault current to flow back to the source, which helps to protect people from electrical shock. The grounding system must be properly installed and maintained to ensure its effectiveness. Overcurrent protection is required to protect the fire alarm system from damage caused by excessive current. Overcurrent protective devices, such as circuit breakers and fuses, must be properly sized and installed to provide adequate protection. It is important to understand all of these requirements before installing a fire alarm system in a healthcare facility. This will help to ensure that the system is installed safely and that it will operate properly in the event of a fire. In conclusion, installing fire alarm systems in healthcare facilities requires careful attention to detail and adherence to code requirements. By understanding the requirements of Article 517 of the NEC and following proper installation techniques, electricians can help to ensure the safety of patients, staff, and visitors. Remember to always consult the latest edition of the NEC and local amendments for the most up-to-date requirements. Also, be sure to check with the local electrical inspector before starting any work. By taking these steps, you can help to ensure that the fire alarm system is installed safely and that it will operate properly in the event of a fire. Furthermore, consider the specific needs of the healthcare facility when designing and installing the fire alarm system. Factors such as the size and layout of the building, the types of patients being treated, and the potential fire hazards should all be taken into account. For example, a hospital that treats patients with mobility impairments may require a more robust fire alarm system with additional notification devices, such as visual alarms and audible alarms with different tones. A nursing home may require a fire alarm system that is designed to minimize false alarms, as frequent false alarms can be disruptive and distressing to residents. By considering the specific needs of the healthcare facility, you can help to ensure that the fire alarm system is effective and that it meets the needs of the building's occupants. Finally, remember that fire alarm systems require regular maintenance and testing to ensure that they are operating properly. The NEC requires that fire alarm systems be inspected and tested at least annually. It is important to keep records of all inspections and tests and to promptly address any deficiencies that are found. By properly maintaining and testing the fire alarm system, you can help to ensure that it will operate properly in the event of a fire and that it will protect the building and its occupants. So, in essence, ensure that all electrical work adheres strictly to Article 517 of the National Electrical Code when working in healthcare facilities, especially regarding fire alarm systems. This includes using approved wiring methods such as EMT or hospital-grade NEC cable, following the raceway guidelines in Section 517.30c, and complying with Section 300.22 regarding wiring in ducts and plenums. Always consult the latest NEC edition and local codes for any updates and specific requirements that may apply to your location. Proper grounding, overcurrent protection, and emergency power considerations are also crucial. Conduct regular maintenance and testing of the fire alarm system to ensure its reliability. Taking these steps will help ensure the safety of the facility's occupants in the event of a fire. Also, remember to consider the unique needs of the healthcare facility, such as patient mobility and potential fire hazards, when designing and installing the fire alarm system. Remember that compliance isn't just about meeting a standard. It's about ensuring the safety and well-being of vulnerable individuals within a healthcare environment. Meticulous planning, careful execution, and ongoing maintenance are the cornerstones of a reliable and effective fire alarm system. Let's also dive a bit deeper into the importance of choosing the right materials for your installation. While EMT and hospital-grade MC cable are both approved methods, the specific environment within the healthcare facility may influence which is the more suitable choice. For instance, in areas with high levels of electromagnetic interference, a fully grounded metallic conduit system like EMT might offer superior shielding for the fire alarm system's wiring, reducing the risk of false alarms or communication errors. Conversely, in areas where flexibility is paramount, such as retrofitting a system in an existing building with challenging architectural features, hospital-grade MC cable can be a more practical choice, allowing for easier routing and maneuverability. In addition to the wiring methods themselves, the selection of appropriate fittings and connectors is equally crucial. These components must be listed and approved for use with the chosen wiring method and must provide a secure and reliable connection. Improperly installed or incompatible fittings can compromise the integrity of the grounding system, increase the risk of electrical faults, and even create fire hazards. Furthermore, consider the long-term maintenance and accessibility of the fire alarm system when making design decisions. While concealing wiring within walls and ceilings can improve aesthetics, it can also make troubleshooting and repairs more difficult in the future. Strategically placed access panels and junction boxes can provide convenient access points for testing and maintenance, minimizing downtime and reducing the overall cost of ownership. In areas where the fire alarm system wiring is exposed, such as in mechanical rooms or service corridors, it is important to protect the wiring from physical damage. This can be achieved by using conduit straps, cable trays, or other protective measures to secure the wiring and prevent it from being accidentally snagged or damaged. In addition to the technical aspects of the installation, it is also important to consider the human factors involved. The fire alarm system should be designed to be easily understood and operated by staff members, even in stressful situations. Clear and concise signage should be provided to identify the location of fire alarm control panels, pull stations, and other key components. Regular training should be provided to staff members on how to use the fire alarm system and how to respond to fire emergencies. The training should cover topics such as how to activate the alarm, how to evacuate patients and visitors, and how to use fire extinguishers. It is also important to conduct regular fire drills to familiarize staff members with the evacuation procedures and to identify any potential problems. In addition to staff training, it is also important to educate patients and visitors about the fire alarm system. This can be done through brochures, posters, and other educational materials. The materials should explain how the fire alarm system works and what to do in the event of a fire. By educating patients and visitors about the fire alarm system, you can help to ensure that they are able to respond appropriately in the event of a fire. Finally, remember that the fire alarm system is just one component of a comprehensive fire safety plan. The plan should also include measures for fire prevention, fire detection, and fire suppression. Fire prevention measures can help to reduce the risk of fires from starting in the first place. These measures may include things like prohibiting smoking in certain areas, properly storing flammable materials, and regularly inspecting electrical equipment. Fire detection measures can help to detect fires early on, giving people more time to escape. These measures may include things like smoke detectors, heat detectors, and sprinkler systems. Fire suppression measures can help to extinguish fires quickly and prevent them from spreading. These measures may include things like fire extinguishers, standpipes, and fire hydrants. By implementing a comprehensive fire safety plan, you can help to protect the building and its occupants from the dangers of fire. The National Fire Protection Association, or NFPA, also provides numerous standards and resources related to fire safety. Consulting these resources can provide valuable guidance on best practices for fire alarm systems and overall fire safety in healthcare facilities.